Modeling in Raidad is done using the Serious graphical editor. This graphical editor consists of three main parts: the palette, which includes elements and subelements; the design environment, which is used to create model sequences; and the properties, which are used to adjust the parameters and hyperparameters of the elements. The first step is to create a process. To do this, we create a process from the palette. A process is an element that determines which sequence we want to create. Its red color indicates an error, so we need to click on it and specify a dataset path in the file path parameter. However, there is still an error. We right-click and select Validate Diagram to show the cause and type of the error, which in this case says that we have not created the import data concept in our model. Since my dataset is in CSV format, I can select the Import CSV element from the Import Data section. However, if I'm unsure about the dataset format, I can right-click on the existing error in the Problems section and select Quick Fix. Raidad, with the help of DMA, will manage and fix the error by automatically determining the dataset format and creating the appropriate concept. Alternatively, I can remove the concept and manually add it to the model, and you'll see that the error is automatically shown when the element is removed. To automatically generate the attributes of the dataset, we use the regular subelements in Import CSV. This ensures that the attributes are created automatically with their respective names and types based on the data. For example, target is of type binomial and age is of type integer. The Data Understanding section is used to provide charts and access various statistical information. For example, the count of each feature, the minimum, maximum, and average values of each column can be observed here. It also shows which columns have missing values and how many, along with bar charts, scatter plots, and other visualizations. Additional concepts such as correlation, visualization, and more can also be included in this section. In the Pre-Process section, various data pre-processing methods are available. For example, managing missing values, normalization, scaling, data transformation, PCA, and other features. In this tutorial, we'll use the simple imputer element, so we add it to the process. If we use Validate Diagram, the errors, warnings, and messages will be visible. The error messages indicate that a strategy for handling missing values must be defined for the simple imputer. It also shows that some features have not been managed and that the connection between this element and the dataset has not been established. There are several ways to create a connection between the elements. The first method is using an edge from the palette. Once the connection is made, the available information is propagated. We can remove this connection and also manually connect the elements using the second method. I still have errors, but I can use the Quick Fix feature in the Problems section to automatically resolve these issues. This will create a strategy for the simple imputer. As you can see, after connecting the dataset to this element, the attributes with missing values are displayed. These attributes are still unmanaged, and the model builder is instructed to handle these attributes. To manage these attributes, I can use the simple imputer parameters and add the specific attribute to this section. I might want to manage each attribute with different strategies and methods. For example, I could add another simple imputer to the process and define a different strategy for some features, maybe using the median instead of the mean, and then create the connection between these elements. I select the attributes with missing values, and you will see that the errors and the names of the unmanaged attributes are automatically propagated and updated. Finally, I can add a KNN imputer to the process and set its number of K values. The connection between this element and the other elements also needs to be defined. Keep in mind that this connection will specify the sequence execution during code generation. After managing all the attributes with missing values, the errors disappear, and I can even use Validate Diagram to ensure everything is correct. In the end, you will see the message that all the attributes with missing values have been managed. I can change the role and type of variables. For example, I click on the target attribute and delete it by selecting the delete option. Then, I return to import data, select target again, and specify its type and name so that it has the target role in classification algorithms. This is because I want to use a classification method. To use classification or clustering algorithms, I can use the elements of these concepts in the palette. I choose the KNN algorithm and establish the connection between this element and the previous elements. After creating the connection, the color of this concept changes. Then, I change the K value from the hyperparameters of this algorithm to 6, so it uses 6 neighbors. To evaluate the model, I can use cross-validation under the evaluation section, and I can also create various charts, such as bar and scatter plots, using its subelements. When I click on cross-validation, I can activate metrics like precision, accuracy, recall, and F1 score for computation. Here, I change the number of folds to 10. If I use validate diagram, I can see any existing errors. For example, before using cross-validation, there must be a classification algorithm, and this error occurs because the connection between the two has not been established yet. DMA also suggests using the scaling concept, such as normalizing or standardizing the data during pre-processing. However, this is just a recommendation and not mandatory. To convert this model into code, I can right-click on the model and select Generate Sample from the Axelio model to text options, which will generate the corresponding code using the transformation engine.